Friends, in this class we will clarify the basic concepts of arithmetic progression. Now what is a progression? A progression is any series of numbers where the next number has a relationship with the previous number and that relationship continues with every pair of numbers. So, for example, if you look at sequence 1, the numbers are 2, 4, 6, 8 and 10. We can find that 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8. So where the difference of previous and next number is same, we call that kind of progression as arithmetic progression. Here A is the first term, which in the first sequence is 2. D is the common difference. But remember, common difference in the formula will always be second term minus first term, or third term minus second term, or fourth term minus third term, and so on. So D in the first sequence works out to 4 minus 2, or 6 minus 4, or 8 minus 6, that is equal to 2. Look at the second sequence, we have 2, 0, minus 2, minus 4, minus 6, and so on. Here also, the difference between 2 and 0 is 2, difference between 0 and minus 2 is 2, and so on. But like before, first term is 2 and the common difference is always calculated by next term minus previous term. Remember, it is always next term minus previous term. So 0 minus 2 equal to minus 2 minus 0 equal to minus 4 minus of minus 2. That comes to minus 2. In the third sequence, we have 2, 5, 8, 11, 14. Here also, first term A is 2 and common difference is given by 5 minus 2 equal to 8 minus 5 equal to 3. In sequence 4, which is 100, 97, 94, 91 and so on, the first term is 100 and the common difference is 97 minus 100 or 94 minus 97 and so on, which comes to minus 3. Now, why do we need A and D? Well, A and D define the arithmetic progression, which means if we want to find any term in that particular progression, that is Tn, can be found by using the formula A plus n minus 1 into D. For example, the 50th term of sequence 1, 50th term of sequence 1 will be given by, in the first sequence, the first term is 2, so A is 2. We want the 50th term, so n is 50. 50 minus 1 into common difference of the first sequence was 2, so into 2. That gives us 2 plus 98 or 100. Similarly, if I want to find the 100th term, of the second sequence, here the first term of the second sequence is 2. We want to find the 100th term, so n minus 1 is 100 minus 1. D, the common difference was minus 2, so we put, in place of D, we put into minus 2. Calculate it, 2 minus 198. So the 100th term of second sequence is minus 196. The other formula that we have is sum of n terms. Sum of n terms of an arithmetic progression is given by n by 2 into twice A plus n minus 1 into D. Now if you look at the square bracket, we break up 2A into A plus n minus 1 into D. Now A is nothing but first term A, and A plus n minus 1 into D is the last term or nth term, or we call it the last term as L. So the formula can be used as n by 2 into twice A plus n minus 1 into D, or n by 2 into A plus L. Now if you look at second sequence and we want to find the sum of first 50 terms, well, n is 50, n by 2 equal to A is 2, so 2A is 2 into 2 plus n minus 1 into D. In the second sequence, the common difference was minus 2. Calculate it, 25 into 4 minus 98, that is 25 into minus 94, that gives me minus 2350. Similarly, in the third sequence, if I want to find the sum of 100 terms, starting with 2, so n by 2 is 100 by 2. First term was 2, so 2 into 2 plus n minus 1 is 100 minus 1, and the common difference in the third sequence was 3. Just go back, common difference in the third sequence was 3. So we write 3 here. Do the calculation. 40 into 4 plus 297. Answer is 15150. These are the only two formulas that we have to use in arithmetic progression. I hope these are clear. Cheers.